Now let's just move on further towards the very special concept of an arithmetic progression, which is all about the sum of first n terms of an arithmetic progression. So let us suppose if I'll ask you that what is the sum of the first 100 terms? What is the sum of the first 100 terms? Then how we can calculate the sum of the first 100 terms? Let's just see. First of all, let us suppose I'm writing the sum of the first 100 terms as nothing but S, capital S, which is 1 plus 2 plus 3 plus so goes on 100. Let us suppose I'm taking this as equation number 1, and now I am reversing their orders. I'm writing them in the reversed manner, means I'm just reversing the numbers as S is equal to 100. I'm taking 100 first, then 99, then 98, and taking 3, 2, 1 at the end, and I'm calling this as equation number 2. Now let's just add the equation number 1 and equation number 2. So if I'm adding both of these equations, so S plus S is nothing but 2S, which is equal to 100 plus 1, means we are adding the first terms, the second terms together, the third terms together, and similarly the last term together. So let us suppose if I'm taking the very first terms, I'm adding 1 plus 100, then I'm adding 2 plus 99, then I will add 100 plus 1 at the end, means we are adding the terms in such a manner, and the total number of the terms over here are nothing but 100 terms. As you can see, 100 plus 1 is nothing but 101, 99 plus 2 is 101, and so goes on 101. So total terms over here are nothing but 100. So at the end, after solving it for the value of S, I will get the answer as nothing but 101 into 100, because 101 is summing up 100 times. So it would be 101 into 100 divided by 2, which is nothing but 5050. Hence, the sum of the first n natural numbers, or we can say the sum of the first 100 terms, not n natural, first 100 terms is nothing but is equal to 5050. Now I'm using this particular method in order to find out the general formula for the sum of the first n terms of an arithmetic progression. So let us suppose if I'll start with the general concept of the n terms of an AP. We know that we can represent the sum as nothing but a plus d, a plus 2d, and so goes on, a plus n minus 1 into d. Let us suppose I'm calling this as equation number 1, and again using the same concept, I'm reversing their order and I'm writing them in the formation of a plus n minus 1 into d, and plus, and so goes on at the end. I'm writing this as nothing but plus of a, and I'm calling this as equation number 2. Now as you can see, if I'll add both of these equations together, so S plus S is nothing but 2S, and further I'm adding the first two terms. If I'll add the first two terms, then we can see a plus a we are getting is nothing but 2a, so this would be 2a plus n minus 1 into d. And similarly the same term we will get if we'll add the second term and the second term over here as 2a plus n minus 1 into d, and so goes on. The last term, in the last term you can see a plus a is nothing but 2a, so this is 2a plus n minus 1 into d. So hence at the end we can see all these terms are actually coming n times. They are coming n times because we have taken the n terms, so they are coming n times. It means 2s is nothing but n into 2a plus n minus 1 into d, and further s is nothing but n by 2 into 2a plus n minus 1 into d, and this is nothing but the sum of the first n terms of an arithmetic progression formula. So Sn is nothing but n by 2, 2a plus n minus 1 into d is the sum of the first n terms of an arithmetic progression. Moreover, you can also write this formula as S is equal to n by 2 a plus n minus 1 into d. We can also represent them in such a formation, and further we can write this as nothing but S is equal to n by 2 into a plus a n, because we know that this is nothing but the representation of the nth term of an arithmetic progression. So S is equal to n by 2 a plus a n. Moreover, we can also write this formula if the last term of an arithmetic progression is given to us as nothing but a n. We know that the last term is also represented by L. So we can represent this formula as as S is equal to n by 2 into A plus L, if L being the last term is given to us in the particular question or in the formula. So these are the three formulas that we can use if we just wanted to find out the sum of the n terms of an arithmetic progression. So S is equal to n by 2 to A plus n minus 1 into D is the very first formula. The second one is S is equal to n by 2 A plus an. The third one is S is equal to n by 2 into A plus L. So this is the general formula of the sum of the first n terms of an arithmetic progression. Now let's just see a remark related to the sum of the n terms of an AP. It says the nth term of an AP is the difference of the sum of the first n terms and the sum of the first n minus terms of it. That is, an is nothing but represented as Sn minus 1. So whenever we just wanted to find out the nth term, then we can use this formula, that is nothing but Sn minus 1, in order to get the nth term of any particular arithmetic progression. So this result holds whenever we have the sum of n terms and n minus term ones given to us. So we can use this formula in order to calculate the nth term. So this is nothing but all about the remark.